Hello, this is Dr. Hanaa Assil, and today we are talking about balancing of ionic equations. So we need to understand how to balance and obtain a net ionic equation. In order to write ionic equations, we write all the chemical formula of the reactants and products. Then we balance the equation, and of course, in balancing, there will be the same number of atoms of each element on both sides of the arrow. And then we write the state symbol if it is required. Remember that a solid is S, a liquid is L, a gas is G, and anything that is soluble in water or dissolved in water is aqueous. So let us take a look at this. And in order to be able to write equations, you remember that some things are diatomic. So remember that hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, iodine are all diatomic. That means a molecule has two atoms, and when it is standing alone, you have to write a 2 under it. So let's take a look at this. In order to be able to write ionic equations, you have to be aware of which substances are soluble in water, and that means aqueous, or which substances are solid or liquid or gas. You have to remember that substances that dissolve in water include any sodium salt, any potassium salt, any ammonium salt. All acids are aqueous, all nitrates are aqueous. Things like barium chloride, copper sulfate, which we use a lot, are all aqueous. For ionic compounds dissolved in water, when we write an ionic equation, we ionize the aqueous substances. So if something is aqueous, we can ionize it. Ionize it means when it dissolves in water, it breaks up into ions. The first one is positive, the second one is negative, and the number of positives and negatives is the same as its valency, if you remember what is valency. If there is something that is solid, liquid, or gas, we do not ionize. We just copy it as it is. Then we cancel the ions that are the same on both sides of the arrow. We call them spectator ions, and that leads us to the net ionic equation. So these are the basic rules. Let's take a look at how we can do it. So if he says write balanced ionic equations for the following reactions, let's take a look at what we're going to write. So for example, we have nitric acid plus calcium hydroxide to give calcium nitrate plus what? First of all, you need to write the basic symbol equation and balance it. How do we write nitric acid? You should remember that acids start with H. Nitric acid is the acid that has nitrate. The valences of hydrogen is 1, nitrate is 1, so nitric acid is HNO3. Of course, I'm assuming that you can at least write a normal symbol equation. How do we write calcium hydroxide? Calcium is Ca, hydroxide is OH. And then we put the valency of one under the other. So if you look at the periodic table, calcium is in group 2. That means valency 2, you put the 2 under the hydroxide. Valency of hydroxide is 1. You don't write anything under calcium. So that is calcium hydroxide. Now, how do we write calcium nitrate? Calcium is Ca, nitrate is NO3. Then the valency of calcium is 2. You remember we put the valency of 1 under the other. So the valency of calcium is 2. You put the 2 under the nitrate. And remember that when we put a number under any of these atomic groups, hydroxide, nitrate, nitrite, ammonium, carbonate, sulfate, phosphate, you need to put a bracket between. So you put a bracket around the nitrate and you put the 2. Valency of nitrate is 1, so we don't write anything under the calcium. Plus water, of course, water is H2O. And then before we proceed, we need to balance. We said to balance any equation, we look on both sides of the arrow. So how many hydrogens do we have before the arrow? we have 1 and 2, so that is 3 hydrogens. On the other side, after the arrow, I have only 2. So you need to balance it by putting a 2 in front of the water. But that means that we have 4 hydrogens and 2 oxygens. Now, the nitrogen in nitrate, calcium nitrate, nitrogen after the arrow is 2, so I needed to put a 2 in front of the HNO3 in order to balance the nitrogens. Now we have, before the arrow, how many hydrogens? We have 2 hydrogens plus another 2 in the calcium hydroxide. We have 4 hydrogens before the arrow. After the arrow, we have 2 times 2, which is 4 hydrogens. Then how many nitrogens before the arrow? We have 2 nitrogens before the arrow, 2 nitrogens after the arrow. Oxygens before the arrow, we have 2 times 3, 6, plus 2, that's 8 oxygens before the arrow, 2 times 3, 6, plus 2, that's 8 oxygens after the arrow. So now this equation is balanced. Now we need to ionize it. And we said in order to ionize it, we ionize whatever is aqueous. So we said all acids are aqueous, calcium hydroxide is aqueous, all nitrates are aqueous, but water is a liquid. And we're going to ionize only the aqueous, so we're going to break them up. The first one is positive, the second one is negative. The number of positives and negatives is the same as the valency. So we have 2H plus and 2NO3 minus from the nitric acid. Calcium 2 plus and 2OH minus from the calcium hydroxide to give calcium 2 plus 2 nitrates from the calcium nitrate plus 2 water. Water is a liquid. We do not do anything to it. We just copy it as it is. Then we look on both sides of the arrow. What is exactly the same on both sides of the arrow? You can see that nitrate ions are the same, calcium ions are the same, so they're cancelled. They're called spectator ions that don't actually take any part in the reaction. So what we now have is 2H plus 2OH minus to give 2 water. Of course, if I have 2, 2, 2, then I can cancel that. So actually my net Ionic equation is H plus OH minus to give H2O liquid. Are we following? Let's try another example. We have barium chloride plus sulfuric acid to give barium sulfate plus hydrochloric acid. So let's write the symbols first. Barium chloride, sulfuric acid to give barium sulfate plus hydrochloric acid. You should be able to write this symbol equation. Then we take a look which one is aqueous and which one is solid, liquid, or gas. Remember that we said we have to balance. So balancing, we need a 2 in front of the HCl, and then we write barium chloride is aqueous, sulfuric acid is aqueous. Now barium sulfate is a solid. It does not dissolve. It will form as a precipitate, so that is a solid, plus 2HCl, which is an acid, so that's it. Which ones are we going to ionize? We're going to ionize anything that is aqueous. The first one positive, the second one negative. So barium is positive, chloride is negative. How many positives and how many negatives? It is the same as its valency. Then we look. Of course, barium sulfate is a solid, so we do not do anything to it. We ionize everything else which is aqueous. Then we look what is the same on both sides of the arrow. 2 chlorides, 2 chlorides, 2H plus, 2H plus. What am I left with? I'm left with barium 2 plus SO4 2 minus to give BaSO4, which is a solid. Now, bear in mind that sometimes he does not give you all of this. He just says, write the ionic equation for formation of barium sulfate. So you're going to think barium sulfate will be formed from what? From barium ions and sulfate ions. So actually, instead of going through all of this, you can just write that barium sulfate is formed from barium ions plus sulfate ions. That is our final net ionic equation that we have there. Okay, and then If we have, for example, silver nitrate plus sodium chloride to give silver chloride, which is a solid, plus sodium nitrate. Again, this is how we write the symbol equation. It is already balanced. Please check to see if it's balanced or not, because it has to be balanced. Then we ionize everything that's aqueous. Any nitrate is aqueous, so silver nitrate will be ionized. Sodium salts are aqueous, so sodium chloride will be ionized. Any sodium salt and any nitrate will be aqueous, so that is ionized. The only one that's not ionized is the silver chloride, which is a solid. Now cancel whatever is the same on both sides of the arrow, and you end up with this net ionic equation. Okay, try doing each equation on your own. Iron, of course, is a solid. Copper sulfate is aqueous to give copper metal, which is a solid, plus iron 2 sulfate, and you will realize that uh, the copper sulfate will be ionized, the iron 2 sulfate will be ionized. What is the same on both sides of the arrow is the sulfate ions, and this will be your net ionic equation. Are we okay with all of this? Okay, so this is a question from the Cambridge IGCSE past paper. So he's saying he has calcium carbonate plus 2HCl to give calcium chloride plus carbon dioxide plus water. And he's saying I want to write it as an ionic equation. So of course the calcium carbonate solid is written as it is. Now, the HCl is aqueous, so I can ionize it. So I will actually ionize it into 2H plus and Cl minus. Now, the calcium chloride is aqueous, so this 2 will be ionized to give me calcium 2 plus, and the 2 chlorides on both sides of the arrow will cancel. The carbon dioxide gas comes down as it is, the water liquid comes down as it is. Another question says the formula for the arsenate ion is ASO4 3 minus. Of course, if you have an ion with 3 minus, that just tells you that its valency is 3. Complete the ionic equation. So he's starting with copper 2 plus and arsenate ion. It will give what? It will give copper arsenate, and already the copper is 2 plus, so valency of copper is 2. You put the 2 under the arsenate. Now, the arsenate ion has a valency of 3, as he writes for you, 3 minus. We put the 3 under the copper. And then we need to balance. If I have 3 coppers after the arrow, I need 3 in front of the copper before the arrow. I have 2 of the arsenate, so I need 2 of the arsenate before the arrow. Are we following? This is another equation, as I said. Sometimes he doesn't give you any reactions and he just says write an ionic equation with state symbols for the preparation of silver chloride. So I'm trying to make silver chloride. Silver chloride will be made from which ions? From silver ions and chloride ions. So for example, in the lab, we do a test for chloride. So I could have something chloride like sodium chloride. Now, if I add silver nitrate, for example, so silver nitrate is aqueous, sodium chloride is aqueous. When we add them, they give a white precipitate. So that is silver chloride, which is a solid. So this is the ionic equation for this reaction. If he says complete the ionic equation for this reaction, includes state symbols. So he's saying chlorine plus something bromide will give what? Of course, chlorine, you know, is more reactive than bromine. So if this is, for example, potassium bromide, then it will displace the bromide and form bromine. And that means I need a 2 to balance. And the chlorine will change into, for example, potassium chloride. So the potassiums cancel and I have 2 chlorides forming. So this is the ionic equation. Then he says include state symbols. What are the state symbols? What's the state symbol for bromine? Remember, bromine is a liquid And the chloride ions, these are aqueous. This question says magnesium chloride can be made by reacting magnesium oxide with dilute hydrochloric acid, and he already gives me the equation balance. So he's just saying write the ionic equation, including state symbols. Of course, we said the solid remains as it is. We do not ionize solid, liquid, gas. HCl has to be ionized to H plus to Cl minus. The magnesium chloride is aqueous, so it has to be ionized. Of course, we said the number of positives or number of negatives is the same as the valency. Magnesium valency 2 will have 2 plus. Cl valency 1 will have 1 minus, but we have 2 of it. Plus the water, which is a liquid, so we don't do anything to it. Cancel whatever is the same on both sides of the arrow and write the net ionic equation. He wants the state symbols. Magnesium oxide is a solid, H plus is aqueous, Mg2 plus is aqueous, and water is a liquid. Write an ionic equation for the reaction of silver nitrate with potassium chloride, and he says a white precipitate of silver chloride is formed. So this is the equation. Silver nitrate is AgNO3, and that is a solution. He tells me it's a solution. That means it's aqueous. Potassium chloride, this is how you write potassium chloride. It's a solution. It is aqueous. All potassium ions are aqueous, all nitrates are aqueous. Now he's saying what is formed is a white precipitate of silver chloride. Precipitate is a solid. And of course, what is left from the equation, if I started with silver nitrate and potassium chloride, this will give what? It will give silver chloride plus potassium nitrate. Is it balanced or does it need balancing? It is balanced. Then we ionize whatever is aqueous. Silver ions, nitrate ions, potassium ions, chloride ions. The silver chloride is a solid, you leave it as it is. Potassium ions, nitrate ions. And then you cancel whatever is the same on both sides of the arrow, nitrate and nitrate. K plus and K plus. What am I left with? I'm left with Ag plus plus Cl minus to give AgCl. Again, this is the ionic equation for formation of silver chloride. Of course, silver chloride is made from silver ions plus chloride ions. This equation says, this question says, write out an ionic equation for the reaction of zinc with silver nitrate. So let's write the equation. Zinc is a solid, of course, it's a metal. Silver nitrate to give zinc nitrate plus silver. And we need to balance it, so we need 2 to balance the nitrates and 2 to balance the silver. Then we ionize. We said we ionize only what is aqueous, so the zinc comes down as it is. Then I have 2 Ag plus, 2 NO3 minus. Then zinc 2 plus, 2 NO3 minus. And the 2 Ags are solid, so we write it as it is. Now, what can we cancel? Nitrate and nitrate. And I'm left with zinc plus 2 Ag plus to give zinc 2 plus plus 2 Ag. This is my net ionic equation. Are we getting better at this? Write an ionic equation for reaction of sodium hydroxide with HCl. Of course, this is the symbol equation. It is balanced. Ionize whatever is aqueous. So sodium hydroxide will be ionized, HCl, NaCl. Water is a liquid, I don't ionize it. I cancel whatever is the same on both sides of the arrow. What is the same? Na plus and Na plus. Cl minus and Cl minus, and I'm left with OH minus plus H plus to give H2O liquid. Another kind of question is the multiple choice. Calcium chloride can be prepared by reacting calcium carbonate with dilute hydrochloric acid. Which one is the ionic equation? Well, let's look. Remember that the solid remains the same. The aqueous will have to be ionized. What am I going to cancel? I'm going to cancel Cl minus on both sides of the arrow. So I'm left with calcium carbonate solid plus 2H plus to give calcium 2 plus water plus carbon dioxide, and that is the equation in B. Of course, we do not ionize anything that's solid or liquid or gas. An excess of powdered zinc is added to sulfuric acid. Write the ionic equation for this reaction. Includes state symbols. So I'm reacting zinc with sulfuric acid. Well, that gives me, first of all, zinc sulfate plus hydrogen. Of course, zinc is a solid, hydrogen is a gas. So nothing happens to them. I ionize the acid and ionize zinc 2 plus. What is the same on both sides of the arrow? Sulfate is the same on both sides of the arrow, and I'm left with this net ionic equation. Another question says the reaction between potassium halide and silver nitrate in solution is this. Which one is the ionic equation for this reaction? Again, I take a look at what is going to be cancelled when I ionize the aqueous. So what is cancelled is potassium on both sides, nitrate on both sides, and that leaves me with the reaction in C. So the X minus, the halide plus silver plus will give silver halide, which is a solid. Copper oxide plus 2HCl to give copper chloride plus water. Which of these will be the ionic equation? Again, I look, what am I going to cancel if I ionize? Well, we're going to cancel the chloride ions on both sides of the arrow, and I am left with the copper oxide solid plus 2H plus to give copper 2 plus the water liquid. When chlorine gas is bubbled into aqueous potassium iodide, a redox reaction occurs. Give the ionic equation. Here he's saying state symbols are not required. If they're not required, don't give it. So chlorine with potassium iodide. First of all, chlorine plus potassium iodide will give what? It will give potassium chloride plus iodine. Then we need to balance. We have 2 chlorines before the arrow, so I need 2 in front of the KCl after the arrow. We have 2 iodine and 2 potassium. After the arrow, I need 2 before the arrow so that everything is balanced. Then we need to ionize whatever is aqueous. The potassium iodide is aqueous, potassium chloride, we said potassium anything is aqueous. Cancel whatever is the same on both sides of the arrow, and I'm left with this net ionic equation. Chlorine plus 2 iodide to give 2 chloride plus iodine. Another question very quickly, sodium carbonate plus nitric acid to give sodium nitrate plus carbon dioxide plus water. Again, to write the ionic equation, what do we need to cancel? We need to ionize anything that's aqueous and cancel anything that's the same on both sides of the arrow. So what can I cancel? I can cancel sodium ions before and after the arrow, nitrate ions before and after the arrow. So what am I left with? I'm left with the carbonate plus 2H plus to give carbon dioxide plus water. That is the answer in C. Barium chloride can be made by reacting solid barium carbonate with dilute hydrochloric acid. Write the ionic equation for this reaction of solid barium carbonate with hydrogen ions from the hydrochloric acid. So what am I going to ionize? The barium carbonate is a solid, so I copy it as it is. HCl is ionized, barium chloride is ionized, the gas or liquid is not ionized, and then I cancel whatever is on the same on both sides of the arrow, and I'm left with this net ionic equation. Okay, another question, complete the ionic equation for this reaction. So if I have copper oxide plus sulfuric acid to give copper sulfate plus water, of course the copper oxide is a solid, it's written as it is. Then I'm going to ionize the sulfuric acid and the copper sulfate. So I have sulfate ions before and after the arrow, and I end up with 2H plus to give copper 2 plus 1. Do you understand so far? Okay, I hope this was helpful, and thank you for listening.